Hello students, in this video we are going to take up a topic from chemistry. The topic is acids, bases and salts, that is part 2. In part 1 we have already done that what are acids and bases, and we have already studied that what are the physical properties of acids. So in this video we are going to learn about the chemical properties of acids. We are going to learn about salts and their types. So let's start. List of topics to be covered in this video. See, introduction of acids and base, classification and physical properties we have already done in part 1. So in this part we are going to study about the chemical properties of acids and bases. We'll study about the nature of metal and non-metal oxide. We'll study about the salts, and these left topics, that is indicators, pH, techniques of forming, separating, purifying salts and controlling acidity for salt will be taken up in part 3. Right. So let's start the part 2. Let's start with chemical properties of an acid. See, the first chemical property is that what is the effect of acid, or what is the action of acid with indicators. See, we have got lot of indicators that we'll be taking up in the next video. Indicators are certain chemical substances which bring about the change in their own color when they are treated with acidic substance or they are treated with a basic substance. So if we treat the acid with indicators, like if we take an indicator that is litmus, then the acids turn blue litmus red. So you can see that the effect of acids on litmus is that it turns blue litmus red. That is, blue litmus solution is turned into red. Right. So this is the first property which we have studied for acids. Let's take up the another property, that is what is the reaction of acid with metals. So whenever the acids react with metal, so what they form metal salt and the hydrogen gas is released. For example, if I have an acid, like say we have HCl, and we take an example of any metal, let's say we take an example of zinc. So it reacts with chlorine to form zinc chloride, and along with it hydrogen gas is released. Another example we can take up, let's say we have zinc and we have another acid, that is sulfuric acid. So when they react, it forms zinc sulfate and hydrogen gas is released. Let's take another acid. Let's say we have sodium and we have another acid, that is HCl. So when Na reacts with this acid, that is HCl, it forms sodium chloride and hydrogen gas is released. So we can say that when an acid reacts with any metal, whether it is zinc, sodium, magnesium, calcium, any metal, it reacts to form a specific metal salt depending upon the type of acid used. But along with it, every time we get to see that hydrogen gas is liberated. As you know, this hydrogen gas can be tested by bringing a matchstick. If you bring a matchstick near the mouth of the container where this gas is liberated, you will see that the matchstick or a splinter, whatever you bring, whether it's candle, it starts burning with a pop sound, which is an identification property for hydrogen gas. So when any gas makes the candle or a matchstick burns with a pop sound and also a kind of pale blue flame, it indicates that the given gas is hydrogen gas. So we have done this activity, and as you can see that we took the test tube. What we have actually used, we have put zinc granules in it and we added dilute sulfuric acid in it. So this is basically this reaction, zinc and sulfuric acid. And sulfuric acid which is used is dilute, that is with enough water. Now this is the tripod stand and this is the delivery tube and this is a container which contains a soapy solution. So what happens? When zinc and sulfuric acid reacts, they form zinc sulfate, and the gas is also produced, which is liberated and via delivery tube, which enters into the solution. And if we bring a candle, you can say, towards the mouth of the container, it starts burning with pale blue flame and popping sound, which indicates that every time when we are reacting, or when the reaction is taking place between zinc or sulfuric acid or any other metal and acid, this gas is liberated. So this property actually proves the presence of hydrogen gas. Another property is action with ammonium salts. So whenever we react some acid with ammonium salt, let's see that what do we get. So let's take an example. Let's say we have HCl, and let us react with some ammonium salt. Let's say we have NH4NO3. So when we react acid with some ammonium salt, what we get to see that NH4Cl, as you can see that here, H is positive, Cl is negative, ammonium ion is with positive valency, and nitrate is negative. So they will interchange their ions and form ammonium chloride, and along with it, what do you get to form? You see that water is formed. Likewise, if we react HCl with another salt, let's say we have NH4OH, that is ammonium hydroxide, then what do we get to see in this case? That it liberates NH4Cl, and along with that it produces water. Another reaction is reaction of metal with ammonium hydroxide. So let's take some acid and we react with ammonium hydroxide, which is NH4OH. So when we react like this, what we get to see? We get salt and water. And we know that salt is a neutral substance, right? So this is a kind of neutralization reaction. As you can see that we are adding acid. Acid means it possesses H positive, and we are using NH4OH, that is ammonium hydroxide, which is having a hydroxide ion. And we know that hydroxide ion that means this given substance is base. So when acid and base react, they form salt and water, that is a neutral substance is formed, and the reaction is called as neutralization. Another reaction is reaction with acids. So whenever acid react with acids, they form salt. Another property we have is action of acids with metal carbonates and metal bicarbonates. So if we use any acid, let's say if we have HCl and we take up any metal carbonate, let's say Na2CO3, right? So what we will get? So just write the valencies. So if you are facing any kind of problem while you are reacting the substances, just write the valencies. The products will be clear to you. So in this case, you know that the positive part will go with the negative. So you will get NaCl, and this H and CO3 will react to form H2O and CO2. So this is what the reaction that take place. So in this case, you get to see the gas evolved is carbon dioxide, and we can just test this gas carbon dioxide by passing through the lime water. When the carbon dioxide is passed through lime water, this is a test for carbon dioxide that it turns lime water milky, right? So if we have CO2 and we have CaOH whole twice, that is the lime water, so it will form CaCO3 plus H2O, and due to formation of the CaCO3, the milkiness appears. So this is the test for carbon dioxide. Similarly, we can react any acid. Let's say I'm reacting sulfuric acid with metal bicarbonate. Let's take the bicarbonate as NaHCO3. So again, if you write the valencies like this, so you'll come to know that Na will react with sulfate ion forming Na2CO4, and the products that are formed are water and carbon dioxide. Again, this carbon dioxide gas can be tested by passing through lime water. So when it is passed through lime water, the milkiness appears due to formation of this calcium carbonate, and along with it water is formed. So as you can see in the figure, in this we have calcium carbonate here, and we are adding it to what to HCl, right? So that means the reaction will take place between them, and it will form CaCl2 plus H2O plus CO2. This CO2, when gets passed to the lime water solution, it turns lime water milky due to formation of calcium carbonate. Another property is reaction with bases. Whenever any acid reacts with base, it forms salt and water. So if you have any acid and you react with base, it will lead to formation of salt and water. So let's take some example. So if I have HCl and I am taking any base, let's say sodium hydroxide, so how they are going to react? Write the valencies. So it will form NaCl, and along with it the water is formed. So that means we get a neutral substance, that is salt and water. So this NaCl is neither acidic nor basic. This is neutral substance, and this reaction is termed as neutralization reaction, because whenever acid and bases react, they form a neutral substance. All acids act as electrolytes in their aqueous state. So if I have any acid, let's say I have HX, and it is in aqueous state, right? That means it is somehow having a water content in it. So it will act as electrolyte, because on passing current, it will dissociate into its respective ions. Like if I have sulfuric acid in an aqueous state and I pass electric current through it, so it will dissociate to form 2H positive and sulfate ions. So that means they act as electrolyte. Electrolytes are basically the substance which dissociates into ions when current is passed through it. So acids can act as electrolyte only when they are in aqueous state. Now let's do the chemical properties of bases. The first property is, what is their action with indicators? As I already told you, indicators are the substances which bring about the change in its own color when acid or base is treated with them. So they turn red litmus blue. So what is the effect of base on litmus? They turn red litmus blue in color. So this is how the bases can be treated with litmus indicator. Another property is reaction with metals. So when metals react with base, they form oxysalt and hydrogen gas is released. So let's react some base. Let's say we have NaOH and we are reacting it with some metal, let's say aluminium. So when we react like this, we get the oxysalt, like in this case, we'll get NaAlO2, and along with it, the hydrogen gas is liberated. This NaAlO2 is termed as sodium aluminate. Sodium aluminate, that is the oxysalt of metal. That is the oxysalt of metal. Another property is reaction with ammonium hydroxide, or we can say reaction with ammonium salts. So when we react base with ammonium salts, let's see what is formed. Let's take a base. Let's say we have NaOH, and let's take some ammonium salt. Let's take ammonium chloride. So what it will form? So just write the valencies. So valencies are like this. So when any base reacts with ammonium salt, like in this case I took an example of ammonium chloride, as you can see in the figure, it will form the salt that is NaCl, and along with it, what you will get as NH3 and water. So that means in this case the neutral substance is formed. Again, this is a neutralization reaction. Next reaction is the reaction of bases with acids. So whenever the base react with acids, it forms a neutral substance, that is salt and water, and the reaction is termed as neutralization. So let's take some example. Let's say if I have HCl and I'm adding a base, let's say NaOH. So what it will form? Just write down the valencies. So it will form a neutral substance, that is NaCl, and along with that we'll get water, that is H2O. So this is what is formed when acid react with bases. So we can have another example. Let's say we have sulfuric acid and we are adding calcium hydroxide to it. So what we will get? Just write down the valencies. So every time when you are writing the reaction, just write down their valencies. The products will be clear to you. So it will form calcium sulfate, as this is positive and this is negative. So they will react and form the salt, that is calcium sulfate, and along with that the water is produced. So again, a neutralization reaction. So every time when acid will react with base, it will form salt and water, and the reaction is termed as neutralization. Another property is all bases act as electrolyte in aqueous state. I have already told you that electrolyte is some substance that dissociates into ions when current is passed through it. So bases can act as electrolyte but only in aqueous state. So if I have any base, let's say if we have magnesium hydroxide in aqueous state, so when it is having a water and current is passed through it, it will break up into its ions like this. So this acts as an electrolyte but only when they are in aqueous state. The next topic is salts. What are salts? See, as we have already done, salts are formed when acid react with base, right? Then we get a neutral substance, that is salt and water. And we have already done that the reaction is called as neutralization reaction. This table salt is an example of neutral salt that is formed when acid react with base. Or you can say it is just a reaction, it is just an example of neutralization reaction. Let's form this table salt. For forming table salt, what do we have to use? HCl, and we have to use a base, that is NaOH. So what do we get? We get NaCl, that is a table salt, and along with this we get water, and because this is neutral in nature, so the reaction is called as neutralization reaction. Now the nature of salts can be acidic, basic and neutral. Every time the salt form is not neutral in nature. It can be somehow acidic or basic depending upon the nature of the acid and the bases which are used while forming the salt. Acidic salt is a salt which is formed when a strong acid reacts with weak base. Let's say the salt can be acidic in nature. Acidic salt is formed when strong acid reacts with weak base. Let's take an example. Let's say if we have a strong acid, that is HCl, and let's take up some weak base, that is NH4OH. So when they both react with each other, what do we get to see? That the salt is formed, but salt is somehow acidic in nature, because you can see that it possesses the hydrogen ions. So these kind of salts which possess hydrogen ions in them are termed as acidic salts. Salt can be basic in nature. Basic salt is formed when the base is strong. When strong base reacts with weak acid. So let's take up some weak acid. Let's say we have acetic acid. This acetic acid react with a strong base. Let's say a strong base taken in this example is NaOH. So what do we get to see? That it will form CH3COO Na, and along with that we will get water. Right. So this salt which is formed is basic in nature because it is somehow possessing the OH ions. Similarly, the salt can be neutral salt. Neutral salt is formed when the same nature of acids and bases react. That means two weak acid and bases are reacting, then they will form a neutral salt along with water. Right? Or you can say if both the acids and bases are strong in nature, then also the salt form is neutral in nature because somehow they are cancelling each other effect and the salt is neutral. That is, neutrality of salt is maintained. So it is formed when weak or strong acid and base react with each other, they cancel each other effect, and as a result the net effect is that salt is neither acidic nor basic, it is somehow neutral. So let's take up some example. So let's do this weak acid and weak base example. Let's say we have a weak acid, that is acetic acid, and I have a weak base, let's say NH4OH. So when they will react, they will form the neutral salt, that is CH3COO NH4 plus H2O. Let's take up the example for the strong acid. Let's say we have strong acid HCl and we have a strong base NaOH. They will react and form salt NaCl and water. Again, this NaCl and this CH3CO's NH4 is neutral in nature. Now, if we talk about the nature of metal oxides and non-metal oxides, let's take up some metal oxide. Let's say we have Na2O, and let's take up some non-metal oxide, that is carbon dioxide. So in both these oxides, you know that this is metal oxide and this is non-metal oxide. Now, what is the nature of these two oxides? As you cannot see hydrogen ions in them and even you cannot see hydroxide ions in them. So how you're going to differentiate them, or you are going to classify them into an acidic or a basic substance or a neutral substance? So what will you do? You will add these respective oxides into water to know about their nature. So when you will add Na2 into water, it will form NaOH. And when you will add CO2 into water, it will form H2CO3. So as you can see that when they are added in water, the metallic oxides are forming the hydroxides and the non-metallic oxides are forming the acids. So I think simply you can make out that all metal oxides, this will happen for all metal oxides, that they will form bases. So that means they are basic in nature. And all the non-metal oxides, when dissolved in water, they produce acids. So that means nature of non-metal oxide is that they are acidic in nature. As I took an example of sodium oxide and carbon dioxide, you can try for different metal oxides and non-metal oxide, but every time you will get to see a base formed in case of metal oxide and acid formed in case of non-metal oxide. Let's do few question and answers. The first question is, write ionized products of these acids and bases. That is, we have these given substances and we need to write their ionized products. That is, when they are added to water, so how they are getting ionized. Now, MgOH whole twice is somehow magnesium hydroxide. So when it gets dissociated or ionized, it forms Mg2 positive, and along with that we get hydroxide ion. So this is how it gets dissociated. Let's try for calcium hydroxide now. Calcium hydroxide is CaOH whole twice. When it gets dissociated, it forms Ca2 positive and OH negative. Let's try for acetic acid. Acetic acid is CH3COOH. When it gets dissociated, it forms acetate ion, and along with that it produces hydrogen ion. Let's do it for sodium oxide. Sodium oxide is Na2O. So when it will dissociate, it will form sodium ion, and along with that it will form the oxide ion. But if the sodium oxide is dissolved in water, so it will form NaOH. When sodium oxide is dissolved in water, it forms sodium hydroxide and it gets dissociated as Na positive and OH negative. But in this case, it was just sodium oxide, so you're going to write only this equation. Next, we have nitric acid. Nitric acid is HNO3. So when it will dissociate, it will form hydrogen ion and it will form nitrate ion. So this is how we can ionize these given acids and bases. Another question is, what is neutralization reaction? So neutralization reaction is a reaction in which acid reacts with base and they form a neutral substance, that is salt, and along with that we get to see water. It is mentioned that you need to illustrate with example. So let's take some example. Let's take some acid, H2SO4. Let's take some base. This is strong acid, therefore I am taking strong base. So we'll get a neutral salt, that is sodium sulfate, and along with that we'll get water. So this is what is neutralization reaction. Next we have is complete the following reaction. So the first reaction we have to complete is barium chloride reacting with sodium sulfate. So barium chloride is BaCl2 and sodium sulfate is Na2SO4. So when they react, you'll write the valencies like this. They will interchange their valencies and you'll get BaSO4, barium sulfate, and you'll get sodium chloride. So this is how the barium chloride reacts with sodium sulfate. Second, we have to do for sulfuric acid and copper oxide. So sulfuric acid is H2SO4, copper oxide is CuO. So when they'll react, if you write down their valencies, so they are going to form CuSO4, copper sulfate, and water. Third, the reaction is dissociation of zinc chloride. Zinc chloride is ZnCl2. When it gets dissociated, it forms Zn2 positive and Cl negative. And even you can balance it by writing 2. Next is calcium hydroxide reacting with ammonium chloride. Calcium hydroxide is CaOH whole twice. Ammonium chloride is NH4Cl. So when they react, they will form calcium chloride. It will form ammonia and water. Next is react magnesium hydroxide with nitric acid. Magnesium hydroxide is MgOH whole twice. Nitric acid is HNO3. So when they will react, write down the valencies in order to avoid the confusion. So it will form magnesium nitrate, MgNO3 whole twice, and along with that you get water. The last is we are adding carbon dioxide to water. This we have already done. Any non-metal oxide, when is dissolved in water, it forms its respective acid. So in this case, carbonic acid is formed. So I think you got it. How you are going to react these substances and what are the required products that are formed. Next question is, what is the nature of dry ammonia? Dry ammonia is NH3, that is, it is not possessing. So let's see that what is the dry nature of ammonia. Is it acidic, basic, neutral, or none? Dry ammonia is regarded as a neutral substance. But if it is having a little amount of water in it, or you can say it is moist in nature. So when it is moist, it forms NH4OH and then it is regarded as a base. Otherwise, if it is mentioned for dry ammonia, it is neutral in nature. Thank you for watching this video. For more learning experience, you can visit our site www.wasrats.com.